So, I know everybody has a notion, an idea what a DevOps is and what, there's various definitions, etc. I just wanted to present our view as we're dealing with clients, what we like to discuss with them, how we want to approach DevOps with them. We see it as a culture, and I'm sure lots of you have heard, Agile is a culture that the company has to adopt, DevOps is a culture that the company has to adopt. A lot has to do with the entire company buying into the idea of faster releases, buying into the idea of horizontal cooperation between teams, etc. So we are handling a lot of that, and we help customers, just gain knowledge and get exposure, what DevOps can do to them, and it's part of building that culture where things start to happen. It's not just bringing the technology. It's also processes, and we like to broaden. Continuous deployment is something that lots of people are familiar with, and they equate DevOps with continuous deployment most often. But we're talking about processes like backup and restore, security management, scaling of security, monitoring, log management. All of those processes for us and for me in particular are part of DevOps, because all of those processes require attention and tools and automation, etc., in order to properly implement them. And I mentioned the word tools a few times. We're talking software configuration management, we're talking automated deployments. I need tools, either write them myself or use some of the tools available on the market in order to really successfully implement it. I wanted to finish by saying that DevOps is a practice, something that you have to apply day to day, right? You're building automation, you're living the automation, and you're thinking about improving that automation. So it's something that you have to practice daily. What tools are out there? I'm pretty sure lots of people have seen at least one or two of these, right? We're talking Chef and Puppet probably being one of those that have been around for a while, and then Ansible and Salt's taking traction more recently. All of these tools are trying to solve a problem in the software configuration management space, from managing different environments, modeling your environments, managing resources, pushing assets, pushing code, managing dependencies in the code, etc. And there is obviously a bunch of other tools that are around the ecospace here. What I wanted to show you is what kind of services does AWS have to offer in the DevOps space that complement or work hand in hand or can be used to replace the tools that I have presented. So the basic tool that many cloud providers and even in VM situations is supported is the ability to push metadata into your servers, the ability to process that metadata so you can manage your deployment. You probably, if you're used to EC2, you probably have run into the concept of user data, and there is a service that became popularized by Canonical from Ubuntu a while back, where that metadata gets processed, and this cloud init service is able to do stuff like run Bash, run PowerShell, run Ruby, bootstrap Chef, and run a Chef client for you, etc. So when you boot your instance, it allows you to configure, it allows you to deploy the necessary dependencies and whatever you want. But there is other higher level services that I want to talk a little bit about today. I'm going to particularly focus on one service called CloudFormation that is kind of unique in general, because it's an answer from AWS about managing all of your resources within your environment. And we're going to see some examples about how to leverage CloudFormation and what to do with it. But many other services have functionality that can be used for implementing automation. And some of them, maybe you've been using them and may come as a surprise. I want to walk you over and see how you can leverage them when you're automating environments. But first thing first, we have a bit of a problem when we look into those existing tools like Chef or Puppet. When I live in any environment, I worry, particularly in a cloud environment or virtual environment, I worry not only about how to deploy the code and the dependencies, I worry about how to provision my compute capacity, the storage, etc. So this is kind of like a blown out picture. Let me see, where you can see what an EC2 instance looks like, right? An EC2 instance is not just a virtual machine that you can start up and do stuff with it. You can attach a bunch of different things to it. You can attach storage, you can attach network interfaces, you can attach, you get CloudWatch metrics and alerts, a bunch of things around your instance are being provisioned, or you have to choose to provision them. So how does tools like Chef or Puppet help you with all that? The answer, unfortunately, is they don't. So you need to figure out a different solution. You live in AWS Web Services, where you obviously have APIs and you can code against those APIs, or you can try to use different tools like Vagrant to try to manage your EC2 instances, or you can use some of the services that AWS provides. So the first thing is, how can I get software installed on my instance, right? This is, as I mentioned, the user data section that allows you to configure the instance. I'm not sure if you can see it from here. Essentially, I'm showing an example where you can pass a metadata to your instance, where that metadata in this particular example is a bash script. And that bash script, given that this is a Linux instance I'm showing as an example, will add start, process this metadata, recognize that this is a bash script, and it's going to execute the bash script. And in this particular case, deploy Tomcat, configure Apache, set up Apache to be a proxy, and start up the services. So this is the most basic example how I can automate deploying things on my instance. This is obviously a very simple example. I also need to push my WAR file, etc. This is just a very small section of what I can do. If I just stick to I'm starting up EC2 instances and pushing scripts to them in order to automate deployment and execution of mine. So this is all great. I start up my EC2 instance, I start up the next one, I do some scripting, maybe I don't like Bash, I'm going to do something else like Ruby or whatever. But I still haven't solved the problem of managing everything else, right? I can do even better than Bash. I can bootstrap Chef or Puppet or something like that, install the client, the agents, and get them going for me. And I can manage my EC2 instances through my Chef server or something like that. But the rest of the things around the EC2 instance are still not being automated. I'm still not really practicing DevOps because that part is still feels like a traditional IT. I still need somebody to click buttons and get EC2 instances, and when they fail, somebody has to restore them, or maybe I don't have backups going, so I keep relying on these scripts deploying things. In order to truly automate the entire environment, the solution that AWS offers, and I quite like because it's very robust and very mature, is CloudFormation. I already used in the previous example CloudFormation template that you unfortunately couldn't see very well. Hopefully you can see this a little better. What CloudFormation does is it allows you, rather than writing code in a certain language and talking to the AWS APIs, it allows you to model your environment. It allows you to model your resources. So it is written in JSON format. We can argue whether that's human readable or not. But the point is that it allows you to define resources, like in this particular case, a Tomcat web server of a type EC2 instance, pass a bunch of metadata, declare a bunch of properties, etc. And CloudFormation will do the work to provision that EC2 instance for you, to touch the right storage, to set up things like IOPS, etc., assign IAM roles, SSH keys, whatever you have defined in your model, right? So we're moving from I'm scripting my EC2 instance to I'm modeling my resource, which is the EC2 instance with a bunch of things around it. True. I'm combining the two. That's a good point. Just CloudFormation alone, without user data, without the ability to push something into the instance and execute something, it's pretty limiting. I'm pretty sure people here are familiar with the concept of AMIs, images. I can go and manually deploy lots of things on the instance, save that as an image, and use that image to start up and have things ready for me. But that's pretty limiting because I may have database connection strings, I may have a bunch of things that are, runtime properties, runtime attributes, credentials, etc. that I don't want to hard code in my image. So in that particular case, I still have to script, right? But the combination of CloudFormation provisioning the environment and the scripting allowing me to provision the dependencies in the software and configure the software is what makes this very powerful. Otherwise, if I didn't, I'm going to just get a bunch of dead instances that I have to hop on and do things on them. By combining the scripting with this, I can get instances that are live, ready to go. They can start taking traffic and they can start producing results immediately just after boot. Another thing I wanted to show you as we are reviewing CloudFormation as a service, they have enhanced the ability to parse and process metadata by implementing another service on top of Cloud Init called CFN Init. So what Canonical has started with Cloud Init, an ability to execute any type of language, any type of configuration, CloudFormation has done something on top of it that allows you to pass metadata inside your CloudFormation template with much richer ability to define resources and define configuration attributes. Like in this particular case, you may have seen some other implementations out there where, for example, I'm managing my Yum dependencies. Sorry, I'm using Yum as a package manager, as a deployment tool to deploy OpenJDK, Tomcat, and Apache, so I don't have to do wget, so I don't have to run installs, etc. myself. But in order for CloudFormation to process this metadata, I have to tell CloudFormation that I wanted to process that metadata. So I still have to do a little bit of scripting, but this scripting is pretty fixed. I'm only passing essentially an error function, and I'm passing a call to this script called CFN init. If you're using most of the stock images that are already out there in the AWS marketplace or the Quick Start console, the AWS tooling will already be deployed, whether that's Red Hat that you're just starting, whether that's Amazon Linux or even Windows. It's going to have the AWS command line interfaces, so you're going to be able to call the CFN init, pass the right parameters, and that allows your machine to then start processing the additional metadata that you have provided. This is quite powerful because it works not only for EC2 instances, it works for the autoscaling service. Not sure. Are many people familiar here with autoscaling? Have anybody used autoscaling? Few. So it's another service that AWS provides where you don't manage EC2 instances directly. You don't go and say launch instance. You actually provide a template called launch configuration to this service, and this service then manages your fleet in a cluster. Decides to, let's say, launch minimum of 2 nodes, and maybe when load increases, you can configure it to add more nodes to handle that load. When load decreases, it can take away those instances, so you don't have to pay more money because there is no need for that. So that service relies on you implementing automation. That service relies on your instances essentially being ephemeral, being launched from some basic image, and being launched with bootstrapping what is going to be deployed on them. So CloudFormation would, the ability to do this on a single EC2 instance, you can easily scale that out and apply it to an auto-scaling type scenario, because the same principle, the same approach applies, and you can use the same tooling, the same scripts. Now, this, I don't know if people will agree this is basic stuff, but in principle, if you have worked with AWS, you've launched a bunch of EC2 instances, you've deployed software, nothing here should really be big news. Maybe you haven't used CloudFormation, so looking at this JSON code there is a little hard, and you're thinking, oh, this is complex, I need to type some commands and scripts, etc. to automate. But the real the real benefit in taking that step, taking that leap and learning a service like CloudFormation and learning a tool like Chef, is that now you can start thinking about expanding your automation to the entire stack. If you look at a complex deployment like this, I know it's not readable, but the point is not to read it, and I'll zoom in a little bit. Sorry. If you look at a complex deployment that has multiple tiers, that scales each tier separately, has a bunch of databases, may use cloud storage like S3, there's a lot to automate. Now all of a sudden, automating a single EC2 instance doesn't feel that complicated, because the entire stack requires a different type of thinking, a different type of approach. I need to synchronize things. I can't start talking to my database from my EC2 instance if my database is not up and running and hasn't been provisioned properly, right? So we're moving from the concept of software configuration management on one node to the concept of orchestrating my entire environment, right? My environment being the stack that I'm building in order to handle whatever application I'm implementing. And another thing I want to point out is that when you adopt a cloud environment like AWS, where you have very basic infrastructure services like VMs in the cloud, and more advanced services like I have a load balancer that I don't have to provision myself. It's called Elastic Load Balancer, ELB. I have a database service that I don't have to install and deploy database software myself. Amazon's relational database service, RDS, can do that for me. When you move from I'm running VMs and I'm controlling everything on those VMs to something like a managed service, where AWS provides a different approach to how things are being deployed, different approach to how things are being configured and managed for me, I can't rely anymore on the tools I'm used to. Right? These are supposed to represent DevOps tools like Chef or Puppet. I can apply them onto my VMs, but I can't apply them to deploy things on S3 and create buckets for me. I can't apply them to configure my Elastic Load Balancer. I can't apply them to configure my auto-scaling, my whatever service I'm using, Elastic Beanstalk in this particular case, to deploy the application. I need to look beyond those tools, because as I mentioned, I've moved from the problem of installing software and dependencies to the problem of orchestrating environments. This is where it gets really valuable for you to look into CloudFormation. And I'm going to keep repeating CloudFormation millions of times, and I feel like I'm advertising it. The unfortunate truth is there is no other solution out there like it right now. I would like to see another solution. I would like to see some competition, so all of them can advance and add more services. But the truth is, this is the only solution out there in the market for AWS, and probably the only solution for any cloud, because there's nothing equivalent to it right now in other offerings, which is unfortunate. So the point I'm trying to make here is that you need an orchestration service to manage your deployment. You need to get your view from what I'm deploying on one node to how I'm going to manage my entire stack. So I wanted to show you a little bit about a project we have done for a client where we decided to leverage CloudFormation heavily. They had a multi-tier implementation where essentially you have a public-facing, what they call a publisher stack, where people can see data sets of different kinds, and a gateway stack in the middle that is orchestrating connection to the different data sources. Some of them can go over VPN to internal data centers. Some of them can be public data sources. And they have decided, for various reasons, performance reasons, isolation, being able to run VPN without allowing others to see data from other customers, they decided that they're gonna essentially create an isolated deployment of these connector stacks and then make it all work together by having the gateway stack be that portal, be that connection service between the publisher and the connector stacks. As we were thinking about the design and the architecture of their deployment, we realized that at each of these different levels, the software running, even though it was different software, required fault tolerance and required some kind of database to support the metadata configuration, to support the data being processed, etc. And we started realizing that there is a pattern. Sorry, I thought I have another slide behind this one to zoom in, but I don't. We realized that there is a pattern that we can take the entire stack and deploy it in such a way that from a deployment architecture perspective, each of the pieces of the puzzle look alike. I'm going to have a load balanced cluster of servers and a database to back it up. So now the problem of orchestrating this humongous environment where I can keep on adding and adding connector stacks and gets even more complex as we go, we decided that we can focus on automating one smaller stack and just reuse the same approach, replicate the approach across the entire stack, and being able to conquer a smaller problem, divide the bigger problem and conquer the smaller problem first before we can address the bigger problem. The other thing that was quite challenging was, in order to support the network isolation they needed to do the VPN, again, don't try to read this. I'm not putting it because I want people to look into the architecture itself, but essentially we had to implement a very fine-grained network segmentation in order to isolate traffic between the different data centers that were running a VPN connection to the environment. So the network itself was fairly complex, and building it by hand and managing it by hand every time a new connector is being added was going to turn out to be quite challenging. So we not only wanted to manage the infrastructure and the deployment of the code and the data in it, we also wanted to manage the underlying network as well. The approach we took was, first we designed the network to follow the same pattern as before. As I mentioned before, each stack gets its own set of segments where different things are being deployed, and then we built a CloudFormation template that allows deploying that piece of the network and then keep repeating to add more and more and more to the network, setting up new VPNs, managing security through an automated way. And this is just a visual view of the different resources that we managed to automate through CloudFormation. So I just want to give you a very, very quick overview that using the service, we have been able to templatize and model things like the VPC environment, the different gateways that manage the outbound traffic to the internet or the different data centers, the different subnetting to manage the IP ranges within the network, the security groups and network access control lists that manage very tightly locking down the security at subnet level and instance level. So all of that we were able to templatize and model, and now it's a click of a button to deploy the initial network, the initial VPC environment, and from then on, it's another click of a button to add a new connection to another data center with everything ready to provision the stack in it, and then the next one, and the next one, the next one. The other thing we did, this particular company was very adamant about not using any of the existing tools out there on the market. They wanted to have no dependencies in their automation tooling, no deployment of any kind of third parties onto their instances. They even had their own custom Red Hat images that were hardened, and lots of things were removed from them. So the challenge of automating deployment became even bigger because our first thought would be, let's use Ansible or let's use Chef. Let's put a little client there on the node, so when they start up, they're going to talk to a server. The server will give them the recipes, and the deployment will be done. Because of the challenges imposed by the requirements, we had to sort of build our own approach to deployment. The challenge was that you need to think about, in this particular case, I'm launching a complete new stack for a new connector that talks to some kind of data set in some kind of data center. Everything is built from scratch. A new database is being provisioned, a schema is being applied, etc., etc. So I had the need to be able to solve the problem of provisioning, and at the same time, this was supposed to be a fault-tolerant deployment, so I had to launch additional nodes that could connect to the database, that could add themselves to the cluster. So it was the provisioning of the additional nodes, as we call them, the HA nodes, the high availability nodes, was very different than the provisioning of the first node that came with a database, etc. So what we have decided to do is, we have decided first to focus on building that initial stack with the first application server and the load balancer and the database behind it, and use that first application server, as we called it, the leader node, to do all the heavy lifting for that initial provisioning. We also built our own homegrown SSH push technology, kind of similar to Ansible, but no dependencies of any kind, that would essentially push a payload to the node and run a bunch of recipe-like kind of commands and scripts that allow us to provision the different stacks, and those recipes would differ from the publisher stack to the gateway stack to the connector stacks, because different type of software was running, different type of requirements had to be satisfied. Now that we have broken down the problem and solved the problem of taking that initial provisioning, what was left was we had to figure out a way how to get that one server scale out to multiple servers. So we built an additional stack using CloudFormation, where we have built the auto-scaling group and the additional nodes, and just similarly to what we were doing with the leader, just push the minimum configuration required into those HA nodes, where they would have like a database connection string, credentials, and whatever they needed in order to go and add themselves to the cluster. No need to deploy additional software, no need to create SSL certs, no need to run database schema updates, etc., etc. So that allowed us to simplify and say, I'm going to break the problem again. I'm going to use two CloudFormation templates, two approaches to build first that leader node and then the additional scaled out nodes. And the other thing that this allowed us was essentially to get rid of that leader node once you're done and get the load balancer to point to the additional nodes that were launched after the fact. So from this point on, I have a fault tolerance stack that can take load, that can auto-scale as needed, efficiently manage performance, and whatever potentially confidential information I have created there is lost. It's being stored in the database, it's being stored in different secure places, but it's no longer found on that initial leader node that I have provisioned, because I got rid of it from the stack. So I don't know how many people can relate and follow the case study, but what I was trying to show is essentially by going outside, let's just use a software configuration tool to deploy a bunch of software, to let's orchestrate my entire deployment. I don't know what's going on.
I don't know what's going on. I don't know why. We can just stop like that.
We have essentially built a workflow. Using the service, we have built a provisioning workflow and a scale-out workflow that allowed us to, with a push of a button, add a new stack to the existing environment. With another push of a button, decide that now we need to scale it out and handle higher load. And on top of that, we also built an upgrade workflow. Now I could push another button and deploy a new version of the software on the running environment as I need it. So I can increase my cadence, I can increase my release schedule and push code updates as as fast as I can afford, depending on my release cycle. Some of the benefits that we've been able to realize by using CloudFormation is that we automated pretty much everything. There is no aspect in the environment, aside from that initial SSH key or IAM role that I had to have available in the environment. There is nothing else that's not automated. So cloning this and creating it in another AWS account, in another region, creating staging, creating different QA environments for load testing, performance testing, whatnot, is cheap. By cheap, I mean it doesn't take effort. Obviously, it costs money to run that infrastructure. But anybody that has access to our tooling can actually do it for themselves. And right now, For example, in that for that particular client, we have about 6 different QA environments. We have a staging environment, a demo environment, all leveraging the same templates, the same tooling. The other thing is everything is code. Every single thing that we have in the environment can be versioned, can be you can do pair programming on it, you can code review, you can keep track of what changes have been done, you can commit your changes into a Git repository or SVN repository with commit commands and all that. So you can keep track of what changes there are to the environment. We have consistently applied to the environment things like performance monitoring, log management, backup and restore. So not only did we automate provisioning and pushing code, we automated all these other things so the operations people can, in any single environment they want to go in, see the same consistent view, see the same metrics, being able to troubleshoot, get the logs out of the environment in a dashboard where they can access them regardless whether this is a QA environment or production environment, etc. Developers can look at application metrics without having to rely on IT or somebody else to do that for them. And then the other thing, and this is something interesting we learned, is that as we were working on the backup and restore, we realized that there is so much we could reuse from that initial provisioning automation that we have built, because when you provision from scratch, essentially it's your provisioning stack without data. When you restore, you're provisioning a stack with data. If you take that approach, in an environment like AWS, that data can be stored on snapshots. So when you provision the environment, you feed snapshots into your tools. The new environment that gets provisioned will run databases and folders and whatnot with data in them rather than being empty, which allows us to essentially take advantage of all the effort we put into that initial provisioning tooling. So now we quickly got our restore process implemented as well, without any special additional different effort around it. So that's CloudFormation. And user data, as I mentioned, which is a key essential part in order to use CloudFormation for EC2. How about the other services? Have anybody here considered, for example, CloudWatch as a DevOps tool they want to use for automation? Or you just use it to monitor the health and the state of things? How about IAM? You probably will agree that IAM is a DevOps tool, but how many people are familiar with IAM? So if you're running any production workload, I'm assuming you have IAM users there and you're able to manage permissions, who can see what, etc. But there's more to the service that allows you to improve your automation. So let's take a look at the different services one by one. One of the problems with any environment is that credentials are needed to access things. And those credentials end up being stored somewhere. To me, when you store credentials somewhere, they're hard-coded. You can say I put them in environment variables, you can say I put them in some key store, or whatever. Eventually, you have something hard-coded that allows you to retrieve credentials or decrypt information, etc. And that's a big problem. That's a big problem for automation, because I want to be able to run sort of without having to put any credentials, any keys, or anything like that on the environment, because I can easily scale it out. I can easily give it to somebody else, makes it more reusable. I don't worry about who accesses what. I don't worry about if I inadvertently checked in my access keys or secret codes or passwords into my code, etc. So while it's not a be-all solution, I still have database credentials, etc., and we are ways away to be able to get to a point where it's easy to rotate and maintain credentials. IAM is using one particular implementation with something called roles that essentially allows you to tag resources in AWS with an IAM role and say any execution of code on that instance against the AWS APIs can retrieve a temporary key and a token that can, then that code can, without any credentials, access the AWS API and do things. And the role being a resource that I can manage, I can limit to what that machine can do, that instance can do. I can say, you're only allowed to download files from S3, for example. So if you happen to SSH or RDP into that box and run the command line interface and talk to the AWS API, the only thing that will work for you is the download from S3. But the fact is there are no credentials stored. The fact is that you don't have to worry about yet another thing to encrypt, yet another thing to protect. All you have to worry about is just apply permissions properly in that role and just tag your resources through CloudFormation or whichever way you decide when you launch those resources. CloudWatch, this is one of my favorite ones. CloudWatch is a service that essentially allows you to publish any type of metric into the service. It has a retention of, I think, 2 weeks to keep those metrics. There's a bunch of metrics that are automatically published for you for free as part of just the platform. When you launch an instance, you get CPU view, you get network in and out information, etc. I think there's about 10 or something metrics that are automatically published, but you can publish additional metrics yourself. An example I want to give to people is I can write a little application that tracks the stock market, and let's say Apple, I'm building some kind of application that I'm assuming that once the Apple stock market goes up, lots of people will download my application, so I want to keep track of that, and I can feed that information in CloudFormation. I can have my application read that information. I can even have my infrastructure automatically scale out when the stock market goes, when the stock price value for Apple goes up. I can provision more instances just to get ready for the hurdle of people, the crowd that will come and download my application and use my application. It doesn't have to be CPU, it doesn't have to be memory, it doesn't have to be disk I/O, etc. Right? It's a general metric tracking system with an API on its own that you can use to put it in automation. And one of the services that I asked before, autoscaling, already leverages this service in order to handle scaling up and down your number of nodes, but you can write your own additional automation on top of it. And it also supports something called SNS notification. So SNS is a service that can call a URL for you, send an email, send an SMS based on an event that has happened and has been published into it. CloudWatch publishes a bunch of events that you configure so that SNS service can call your endpoint URL, your application. You're going to know that an event has happened somewhere in your system. Let's say your database started spending more CPU cycles, and then you can do something in your code about that. Start throttling, decide to launch another read replica, a bunch of things that you can do based on that information. I already mentioned autoscaling. It's essentially a service that allows you, rather than writing code, to keep track of what's going on with your environment, keep track of the load. You write these policies and alerts that automate replacing nodes in the environment when they're not healthy, automates adding more nodes when more capacity is needed because the load has increased, removing nodes to save you some money because there is no more need for such that much capacity, etc. So, not a lot to say, just a way to avoid you typing code and working your way through the API to understand how to do it. Autoscaling has automated that for you, so it's another tool that you can leverage. The services that I'm presenting next are truly services that are built especially from the ground up to support managing your deployments. I mentioned CloudFormation being this cool service, unique, can provision everything. There is a limitation. It's only useful for provisioning your new stacks or restoring your stacks. It's not useful for pushing new code. It's not useful for pushing new configuration. It's great if you want to change things like I don't want to run on small instance sizes anymore, I want to run on mediums or larges. It can make those updates for you, but it's not going to push a new WAR file for you in your Tomcat deployment. It's not going to push a new ASP.NET application in your IIS cluster or anything like that. So you're gonna need the service. You're gonna need some kind of tooling. And this is where a Chef server comes in handy. If you're leveraging that, great. You can use Chef to push your code as a new update onto your nodes. But what Amazon has done is they have built their own approach, their own service called Elastic Beanstalk that can work in many typical web deployment scenarios. So essentially they have introduced the concept of a web container, which can be Tomcat, which can be Apache, which can be Unicorn, which can be IIS, there's a number of different containers that they support. So essentially Elastic Beanstalk will go and provision your container, will provision the load balance cluster, can provision the database for you, and then can automate pushing your code, whether it comes from your continuous integration, for example, Jenkins, or if you're using a scripting language like PHP, for example, it can push it straight from your Git repository or whatever source control system you're using. It allows you essentially not just to provision and manage your environment, but to manage your release cycle as well. What's cool about that is built on top of CloudFormation, so there are some very interesting scenarios how the two of them can be used together. So CloudFormation can provision pieces of the infrastructure like a DynamoDB table or an Elastic Cache cluster or whatever that Elastic Beanstalk cannot do for you. And the two of them together can work very well together. The other service along these lines is OpsWorks. You may have heard of that service as Amazon's answer to Chef. It's really a solution that allows you not to have to deploy and manage a Chef server yourself. Obviously, you can do that. Spin up an EC2 instance, deploy a Chef server, run it, and manage your deployment. But it's a solution that allows you not to worry about the server side of things. OpsWorks manages your cookbooks and recipes. OpsWorks allows you to define your different layers in the application and choose which cookbooks, which recipes to be applied, and when to put a new update. So if you're a company that has committed to Chef, you have a bunch of recipes you want to use, you have people who are quite familiar with it, this is a nice way to move from managing extra infrastructure just so you can leverage Chef to rely on Amazon to manage that infrastructure for you. All you have to do is just manage your cookbooks in something like Git and hook that to OpsWorks, so OpsWorks can manage all your dependencies and all your recipes for you. Finally, another service that is a little less mature and often overlooked by people who are trying to do automation in AWS. Most often, and I've seen this so many times, people that are doing web application or even different kinds of application, they would run some kind of jobs against their application, against their database. They might be aggregating stats, they might be exporting data from one format to another format, etc. And those jobs, when you run a single virtual machine, often run on that machine itself. You don't provision another virtual machine to run them. When you move to a clustered environment, where your nodes are fully automated, they might be working in auto-scaling, they can disappear at any time, and they can compete. If you have 3 nodes, you don't want to put your jobs, your cron jobs, your Windows tasks, whatever, on each of those nodes. Or go to the trouble to say, one of these nodes is special, I'm going to run jobs on it, the other servers are not going to run those jobs. When you lose that server because it crashed, your job stops working as well. So you need a solution that takes your jobs out of your cluster and puts them somewhere else. Obviously, you can run an EC2 instance and deploy those jobs just like any other software and run them there. Data pipeline is an interesting solution that allows you to, again, apply the principle for managed infrastructure. This is one recurring theme in AWS is that there are common infrastructure services that you would typically provision and manage yourself, and you have to worry about lots of things about them, and say, no, I don't want to do that anymore, it doesn't add value into what I'm doing, and you can push that to AWS to do it for you. So data pipeline essentially is a glorified scheduler that can run these. You can run jobs. It's going to provision compute capacity for it. It's going to deploy the necessary dependencies, run those jobs, provide connectivity to RDS databases, Redshift instances, and whatever your resources are as 3 buckets. Your jobs will finish their thing, and when they're done, that infrastructure goes away. When it's time to run them again, data pipeline will provision the compute capacity, manage all that for you, etc. So it's an interesting way to expand. Okay, now I'm cool, I'm great, I'm running DevOps, I have managed all my web deployment or whatever infrastructure, but I have this utility server and some rendering server and some job running servers here on the side that I manage like a traditional IT manually, and I have people on it constantly doing things, etc., etc. I have to back it up because if you lose the stuff on it, I'm hooked. It doesn't matter that I have automated everything else. So this is one interesting solution. As I mentioned, it's a little less mature than some of the other ones, so you might have to deal with some issues, but I'm expecting that they'll invest more and more into it, and it can be useful for more than just running jobs. It is already pretty useful if you're running MapReduce algorithms using Hadoop, where it can provision your Hadoop cluster and allow you to use S3 or DynamoDB rather than HDFS. So you probably will see news in the next year coming and this service improving. And personally, I believe that in the next year we're going to also see more features to the services I have went through, and even new interesting services that are heading in the direction of automation, right? Everything that you do in AWS, if you truly want to adopt DevOps, if you truly want to make your life easier and run more complex deployments more often and allow more testing to happen before you push new releases, you need to leverage all these services. Otherwise, you're going to find yourself where you're fighting lots of fires, servers are being lost, you have to keep on restoring things, lots of manual effort is required. By leveraging these services, much of that work is being done for you. You just obviously need to learn how to use them, but once you learn how to use them, you're going to be able to automate all of the aspects of your environment. I think that's it. I was going through, didn't see anybody itching to ask a question, so I decided to complete, but now I would say it's open for questions if people have questions. Thanks.
For that pipeline you have, so does it have time guarantees, or is it like, have like revenue queue or releases or something like that, where you just pull stuff off of
So
reviews?
I believe the question is, would data pipeline have any time guarantees? I believe currently the implementation is not precise down to a millisecond. It's like if your run takes longer, the next schedule, the next run will be delayed, right? It's not going to skip a run, it's not going to guarantee that, it's not going to parallelly run 2 jobs. It is at the end of the day a single workflow, a single kind of, I don't want to call it a thread, but yeah.
What's the cost of running a chef server managed versus running your own? Like, is it significantly worth it? Or?
Yeah, so that's a really great question around if I decide to adopt, let's say, OpsWorks to let Amazon manage the chef server side of things for me versus doing it themselves, what's the cost difference? All of the services I've mentioned, CloudFormation, OpsWorks, Elastic Beanstalk, they're free. So whatever capacity, whatever compute cycles Amazon uses to actually run and process things, you don't pay for those. What you do pay is the infrastructure they provision for you. Any EC2 instances they provision for running your code, you pay for them. Any ELB instance you provision for load balancing, you pay for that. Any database they provision for you, you pay for that, right? But the management services around them are free. There is no extra fee. So if you run your own chef server, that means you need to stand up an EC2 server, and you pay for that. If you use OpsWorks, there is no extra cost, right?
Okay, so is there cost for adding servers to Valve servers, or is that all in there?
I didn't get that, sir?
So is
So when additional nodes are being added, because there is more load, or because you use TopsWorks to say I want to scale, those nodes cost more money, right? The more nodes you add, but hopefully that's a function of load, which hopefully equates to more money for you, right? Unless you have a freemium or something like that, where it doesn't equate for more money. Otherwise, yeah.
How do you do development right then? Do you have like a script for just setting up what you need for all your dependencies like S3, SQS, and all that stuff, and then you run the apps locally to do development? Or do you set up a cluster and then log in and do all your development on EC2 instance?
I see. So the question is, when you're trying to automate like this, how do you actually develop your scripts to do the dependency management?
Not the development, just the application. Say I have like a new engineer coming on, how does he get set up to develop? Does he wire everything by hand, or does he actually use the cloud foundation?
So it is possible that you can use the cloud formation to provision. I mean, I've seen companies where they say, I want an environment per developer. So you as a developer get your own SQS, get your own Elastic Cache instance, get your own MySQL RDS instance, get everything. And you're working off of your laptop or desktop against those resources, right? And there are companies that say we're going to share, we're going to create a dev environment. Now, those companies that decide to share often are doing it by hand, standing up those instances by hand, because it's done once and then shared by many developers. Those companies that prefer that each developer gets their own environment, they like automation because a new developer comes, the onboarding process is to push that button and generate that environment for them and give them a script that maybe they can run on their desktop to set things up for them so they can start working, right? It really depends what mindset you want to adopt. You can go as far and say, each of my developers gets a branch in my Git repository, and that branch maps to an environment that I'm managing through CloudFormation and Elastic Beanstalk, right? So you can wire all that together, and then obviously you move the program to merging, now how to merge all those branches and how to manage my releases and all that, but at the same time, that's a known problem that AWS doesn't make worse or better, right? It's a software release management. So did you have a question as well?
I have an answer for you, maybe. The way I've built it is I've got my development environment, and I use Vagrant to spin up the environment as VM, so I can test very easily my script, my bash script. And you can use, if you want to have your guys develop on the AWS, then you can have a Packer, which is done by the same guys as Vagrant, to take that VM and all the provisioning of it, and target an AMI on your AWS, and you got the exact same VM that you develop on your machine up there. And you can have all the latest code base because you can ship it with it.
It would be expensive having your developers working in Amazon, so if you can keep most of the developers,
It depends what they're doing, right? If your application relies on SQS, you may have no, or DynamoDB or something like that, you may have not much choice.
Yeah,
Right.
I'm just wondering, because I like the idea of having everything scripted and be able to say, run the script, you'll be set up, and start working.
Yeah.
So,
I just wanted to add, Vagrant is an interesting service, has been maturing and adding more and more functionality. I think now they even support ELB. They start supporting more provisioning than just basic VMs. There is some ways to go to support, for example, what CloudFormation can do, but a service like that allows developers to work locally and use virtual boxes instead of EC2 instances and stuff like that, and then move to the cloud. So as you mentioned, it gets cheaper that way. More questions?
How do you manage updates to your code base, basically?
So, how do you manage updates to your code base? You have to use a tool like Chef, or you can leverage a service like Elastic Beanstalk or OpsWorks, right? Nothing else there exists right now unless you build something yourself that can manage code updates. CloudFormation, as great as it is, and it covers all these things, it's really built to manage your infrastructure resources, not the code, right? If you're dealing with managed resources like RDS or ELB, for example, it can manage lots of aspects for it. It can, for example, put an SSL cert into the ELB, set up your listeners, initiate the backup procedure, set up the automated backups, etc. for RDS. But even there, for example, it's not going to run, I don't know, Liquibase or Flyway to create your SQL schema on the database, right? You'll need something to run that for you. So if you're using something like Chef, you're going to be able to use your Chef server to push deployments, or Sol push something to your minions and they're going to apply the code update. If you are using something like Elastic Beanstalk OpsWorks, you can use the functionality built into those services that can push those changes into your
What does it do in terms of patch management? What does it do in terms of patch management for the services?
Nothing. So neither OpsWorks nor Elastic Beanstalk would automatically patch your servers. You'll have to script that. But well, that's an interesting one because what we're discussing here is I want a full control over my environment. It's not just pushing code updates. I want the latest patches to be applied, right? So I have a running environment. How do I push patches to that environment?
Well, I want to control, right?
Yes.
I don't want to just push up patches. That makes sense.
So, and I was gonna lead into one very interesting feature that was added recently, something called, actually two features, connection draining and rolling updates. In order to reduce the risk of changes like pushing a new Linux patch or increasing my instance type for small to medium without outage, without downtime, planning a weekend maintenance window, what you can do is, if you're leveraging the ELB load balancer rather than rolling your own, in ELB you can configure something called connection draining. So what does that mean is that when you decide to take an instance down, the system will wait until there are active connections. When all the connections, all the requests are being served, no new requests are going to be sent to that node, and that node will be taken out, and a new node. Then the new node that was provisioned will start taking the traffic. The other feature is, it is a CloudFormation feature, it's called rolling updates. If you have your cluster in an auto-scaling group, what if you decide to push an update to your cluster, what CloudFormation can do is, they can take down one node, replace it, and wait. Take the next node in line, replace it, and wait. So they're not going to just take the entire infrastructure down, right? So the point is, if you decide to push an update like a Linux patch and something causes a trouble to your environment, right? Thanks to rolling update, it's going to stop after the initial one because it's going to decide that it's going to keep a minimum set of nodes in your cluster. It's not going to allow the update to continue.
Can you incorporate satellite server into this?
Sorry?
Satellite server. So I had satellite server into.
I'm not familiar with the service.
It's just a patch management tool that Red Hat provides. I want to incorporate that, like another piece that's not standardized into CloudFormation.
You want to be able to manage it as a release, so you decide when to upload patches?
It's
Yeah.
it's like an extra layer, right? So like there's CloudFormation and then for my deployments, I'm going to do CloudFormation and patch management.
Yeah. I mean, we, for example, for a client, we decided they want to use Kaseya. I'm not sure if people have heard of the service. It works nicely to remotely manage Windows instances. It can support Linux instances as well. It can be used for patching Windows instances behind the firewall. If you're behind the firewall, you can't RDP into an instance, but the instance can call into a server. So we have automated deploying the agents. So So whenever a new instance pops up, right, it's going to automatically call home and say, hey, I'm alive, are there any patches? And then you can manage through the Kaseya service. So kind of similar to what you're describing, if there is an agent that I can automatically deploy or a client or of some sort, then I can manage them through the main service. I don't know if that's related to what you're describing.
It's okay. I'll ask.
Okay.
Sorry, thank you guys.
Can you tell me, your experience with cloud formation, like how large that JSON file can be with your past experience in your time? Like a C would be a very huge file.
It doesn't have to be one file though. I don't know if I can show that.
You can split it up into logical.
Yeah, you can split it up into logical substacks and put the substacks together as a single stack. Sorry. Anyway, I mean, I don't think we need the picture. So there are limitations. I can't remember what are the limitations, how large the JSON file can be. If you can split it into logical pieces, let's say I have a piece that manages my, I don't know, MKHD cluster, another piece that manages my RDS, multi-AZ with replicas, another piece that manages my VPC, they're all different JSON templates. Right? And I can have another JSON template that says environment.template, something like that. It says, I want this stack, and this stack, and this stack, and this stack, and I can wire them by passing values between them, so I don't have to copy-paste anything, right? So that allows you to, just like code, right? After a while, your code file becomes too big, you split it and you include, so, yeah.
Can you recommend any particular tools which spit out cloud formation templates? I know that for I think VisualOps has an option. Any others?
It's a very, very interesting up-and-coming tool. I haven't played myself a lot with it. There is a tool we use a lot. A tool. It's a framework called Pipelates. So essentially, you can write dictionaries and structures in Python. So you can use logic, ifs, and whiles and whatnot to build your resources. And then Pipelates can generate the JSON template for you. And we use that a lot. And we've been coming up with our own higher-level abstraction in a YAML format. And then we built our own scripting that processes the YAML and spits out the different JSON files for us, right? But VisualOps is the only tool that I know where you can visually sort of draw your environment and then say export to CloudFormation is going to create that template for you. I don't know how powerful and how.
I have read past it.
Yeah.
Reinvent.
There is one reinvent.
There is another tool you may want to try. I'm sure it's going to choke on your environment. It's called Nephoreader, Nephoreader. You can give it access key and secret code with read-only access, and it can try to visualize your VPC and EC2 instances, etc., and give you different information about it.
I use the Amazon provided little micro instance that you can spin up in CloudFormation to generate one-time template of your existing infrastructure.
Yeah, no, that's pretty limited. That's great for learning.
It's very limited, but it sure made a big file.
Nephoreader tries to visualize it.
Okay.
It doesn't spit out a CloudFormation template. It's going to visualize your VPC and different instances, but probably it's going to choke on your environment. Nephoreader, Nephoreader. Lots of tools are coming like this. VisualOps is a very interesting one. I want to keep track of it and see where it's going to go.
Does it alert you, with live, if there's something break within the infrastructure, or is it just show you a map?
It's going to show a map, yeah. And right now you have to keep on running it. It's not going to sync it, right? More questions? All right, thanks guys. Hopefully this was not too boring.